So again, thanks for signing up for this webinar that is about Agentive UX. And I'll be talking about both designing with AI technologies as well as designing for AI technologies. This is the agenda of what I'm going to cover. So I'm going to start with an introduction about myself and about this topic. And then I'm going to start talking about designing with AI and specifically AI tools used in user research, UX research, as well as AI for interaction design and prototyping. And then I'm going to talk about designing for agentive systems and some principles of AI UX design. And finally, I'll talk about how we approach AI in Art Center's graduate interaction design program, and I'll share a little bit about that program. And there will be time for Q&A at the end. So if you have any questions, you can feel free to put them in the chat or you can save them for the end. So first of all, a little introduction of myself. I'm the Associate Chair of Graduate Interaction Design at Art Center College of Design. I've been teaching at Art Center for more than 8 years now. And in total, I've been teaching for about 30 years now. And I'm also a working design professional. My expertise is in HCI, human-computer interaction, HMI, which is human-machine interactions, so kind of the physical interactions. And I also do future casting and speculative futures design as part of my practice and also part of my curriculum. My work experience, I've worked at NASA GPL, Intelsat, some other aerospace companies. I've spent a chunk of my aerospace. Also done work with Hitachi as a futurist in residence for Hitachi's R&D division. And I've done some bigger projects also with the European Union Commission and Idea Lab and a handful of tech startups. My educational background, I started my education before there were any formal degrees in the field that I work in now. But I did an MFA at the Dutch Art Institute in experience design. I worked a lot kind of in experimental experience design. I did a master's at UCLA in film and television, and my concentration there was in digital filmmaking and multimedia. So a lot of that actually kind of fed into the UX design field. And then I did my bachelor's at Pitzer College. My major was in media studies, but I kind of did a smattering of multimedia and some graphic design and some video production and a bunch of kind of liberal arts and social sciences as well. So I was very broadly curious. And between those, my career kind of started in multimedia production and graphic design in the mid-90s, and then it kind of evolved in the early 2000s into UX. And I started to sort of develop that UX practice in the late 90s and early 2000s. So I've been working in this field virtually since it was invented. Now, talking about Agentive UX, the title of this talk, what is Agentive UX? And so I think of Agentive UX as the design of user experiences where AI acts as an autonomous assistant. It's working on the user's behalf to accomplish tasks. And unlike traditional tools, Agentive systems take initiative and they operate continuously. They can often do this without direct user input, although oftentimes they're designed to sort of wait for user input. Designing for Agentive UX requires new thinking around trust, around control, around feedback, around collaboration between humans and intelligent systems. And so I'm finding that UX designers and interaction designers are increasingly working with AI tools as creative collaborators. So they're using the tools to help generate ideas, to help create prototypes, to extract user insights from data sets in ways that are faster than ever before, and oftentimes requiring fewer human resources as well. And so this shift is really transforming the design process into a partnership where the human intuition and the machine intelligence can co-create design outputs. And there are some hazards along the way, and I'll talk about those a little bit later as well. Now, Agentive UX is a design approach for systems where AI doesn't just assist, but it also acts on behalf of the user. And so instead of merely responding to user commands, AI agents can initiate actions, they can sometimes make decisions, and they can perform tasks on behalf of the user. And so Agentive UX transforms design from a command and control interface into intelligent environments that respond and learn and that act proactively. And so this is shaping, not only how we're designing as designers, but also how people are interacting with technology in a variety of different contexts. Now, there's some different types of AI that I'll be talking about. And so some are assistive, some are agentive, and some are automated. And so talking about what the difference is a little bit between these things. When we talk about assistive AI, this type of AI supports users by enhancing their abilities. And so things like autocomplete or spell check. We've had assistive AI actually since the 1990s, it's been around a long time. So this, again, it enhances users' abilities, but it keeps users in full control of the system. So users have to interact with the system in order to make it do something. Automated UI is at the other end of the spectrum. This is AI that performs tasks entirely on its own, and oftentimes without user involvement. And so things like back-end fraud detection or server optimization. These are automated tasks that happens without a user having to do anything. A lot of us have fraud detection on our credit cards or with our bank accounts and things like that, something we don't think about. And that tends to be the case with automated systems. And so you stop thinking about them because it does it for you. You don't really have to think about it as a user. Now, Agentive AI occupies a middle ground. And so Agentive AI acts on behalf of the user. It takes initiative, but it remains under human oversight. And so it's like a scheduling assistant, for instance, that books meetings for you. You can be, there talking with or interacting with the AI agent as it's doing the task, but you're the one sort of directing that task. And so designing for agentive systems requires balancing autonomy with transparency, as well as with trust and user control. And it's really an entirely new area where UX designers and interaction designers are operating. This is an example of a site called UX Pilot that will auto-generate ideas for websites for you. So I had asked it, it's an agentive system, so I have to interact with it. I give it prompts, I give it text prompts about what I wanted. And I basically had to create a very sort of generic site for my UX design business, my generic UX design business. And it does it very competently. This looks like a very typical kind of professional UX service. Services are listed here, very typical services of a UX designer. There's usually a selection of work from your portfolio to give some examples. Little about me section. That's not actually me. That's just a random image it selected or probably generated that image from AI actually. Some customer quotes, endorsements and things like that. These are things that I could use as a starting point. I can start to tweak the design, but I'm essentially working with the AI agent to create this site. I can then go in and customize it by hand or continue to work with the AI agents. So this is an example of agentive technology, and it's representative of a lot of the new AI-based technologies that we're seeing, especially in the last year or year and a half, let's say. So what we're seeing is, the impacts of these technologies are creating this seismic shift in the interaction in UX design fields. Now, a lot of you, if you're designers, not even necessarily in UX, but adjacent fields in graphic design or product development, brand design, things like that, you're probably familiar with some version of the double diamond model of design processes. And so for UX design, this traditional double diamond model outlines this kind of structured and phased process that starts with discovery and it goes to delivery. And there are variations of how different agencies and whatnot sort of diagram this. But the essence of this model is that designers are personally conducting the activities within them. User research, for example, interviewing participants, synthesizing findings, mapping insights, creating customer journey maps, mapping user flows through a digital system, even doing some ideation, some early prototyping as a form of research, some lo-fi concepts to test some early hypotheses. Then you move to the second phase of the diamond, and you're engaged in producing progressively from low to high fidelity prototypes, testing prototypes, testing mock-ups, doing usability testing. You might even be doing like brand testing and things like that. Developer handoff, whoever is going to be developing the digital product you're working on, and then continuing to support the implementation of that product as it continues. But in any case, this process, it's very human driven. It emphasizes craft, intuition, close contact with the users, and this approach gave designers full control and deep engagement throughout the journey. And it's one that I've practiced, for decades now in my career. And I find that, there's of course variations on how this is implemented in the real world. Of course, companies love to try to cut research as much as they can, and so this is not sort of always ideal like this. But it's in general a pretty robust model that produces good results if it's executed well. However, it can also be time intensive. It's very sequential, makes it kind of a waterfall method. It means you can get stuck in part of the process and not be able to make progress. And it also requires clear handoffs between each phase in order to function. Now, as we're introducing AI tools throughout this entire process, it's touching everything that we do. And so that traditional double diamond model, UX design, is now being disrupted with this new wave of Agentive tools that are blurring the boundaries between the stages, and they're accelerating the whole process. And so tasks that used to require weeks of manual effort with maybe a team of designers or researchers, things like analyzing research data, generating personas, mapping user journeys, clustering insights, doing competitive analysis and things like that, can now be performed in hours or even minutes using tools like user testing AI, UX Pilot, UiZard. So these are some of the tools I'll show you in a little bit. There are also like coding tools like Replit Ghostwriter that supports interactive prototyping with real code. And so you can go from low to hi-fi and also working code kind of in a single step. Testing can now be done faster using predictive AI moderated studies. And so things like Maze.io is a tool that's been around. They're now infusing a lot of AI tools within their user testing and research suite. There are things like behavioral simulations, using things like this platform called Attention Insights that will basically simulate what would happen if a real user tested your product. They actually don't have real users testing your product, so it's an AI simulation. And they can give you what they claim to be, accurate insights about the usability and desirability of your product. For post-launch, agentive systems can be employed to continuously monitor feedback and performance in real time, even things like collecting qualitative user data and giving real insights into that. And so as a result of all of this, the UX workflow is shifting from a staged linear process to a more dynamic integrated ecosystem where research and design and prototyping and evaluation can happen concurrently and continuously throughout the process. So I didn't even attempt to re-diagram this. I don't know what the diagram is, but the diagram is in flux and the two diamonds are starting to blur together. And you can see here how AI tools are sort of injecting themselves at almost every step of the process. And that's really kind of changing in real time how we're working. It's something we're still kind of in the discovery phase in many ways. So two of the big shifts I think that are happening is that UX design is shifting from manual manipulation of interfaces to active collaboration with AI. And so before, you were designing UIs basically for people to go in and click on buttons or manipulate data in other ways to basically operate the interface. And so that's shifting now. Instead, you can go and interact with an agent, and the agent is actually the interface. So designers are also working more on kind of shaping workflows that are integrating intelligent, responsive tools with user interactions. And so instead of clicking through static screens, users are increasingly engaging with systems that anticipate needs and offer proactive support. And so agents can ask the user what the user wants, but also agents can also predict that and start to make suggestions and make decisions ahead of time. And so with websites, for example, and mobile apps, we're moving from dynamic but predictable UIs to adaptive agents that are learning how to evolve and personalize over time. We're seeing that with some of the agents now. They can remember your past conversations, and it can feel a bit like you're developing a sort of personal relationship with them. But these shifts also are requiring new design approaches. They're focused not necessarily on UI layouts, but instead on user behavior, trust, and building long-term human AI relationships, working relationships. So in this next section, I'm going to talk about designing with AI. So some of the tools that we're actually using as UX designers or as interaction designers. And with those tools, I'm going to start with UX research tools. So we'll start at the research end. And most of the research tools out there are really focused around analyzing large user data sets. And that's something that AI is really good at, is working with large data sets, automating and scaling user interviews. And so, conducting user interviews and recording and coding that data is very time consuming. That's something that AIs can automate and speed up. And then also generating user personas, which is an activity as part of the research synthesis. And it's producing an artifact from the research that's then usable in guiding the design process. So I'm first going to share an example of a project that I actually did for my own consulting business. And so, and this was persona generation. So this is a survey that I did for my own consulting business in the fall of 2023. So this is just a couple of years ago. And I did a large survey of 1,000 participants. And the specific demographics that I was screening for was I was interested in working class American Gen Z who did not live in kind of the big coastal cities. So the working class Gen Z who are working in the Midwest and the southern states in the U.S. And the reason why is because I was working on designing kind of future educational products, and I'd seen a lot of studies about the sort of preferences and behaviors of Gen X users, but I recognized that in the studies that have been published, they mostly focused on Gen X users who were coastal, highly educated, and from large cities. So from places like LA and San Francisco and New York, those were kind of the big prime places where they were getting their research data from. And I thought, well, there's probably regional differences, and there's probably some socioeconomic differences as well. So I was interested in discovering, are there differences there? And if so, what are those differences? And so I surveyed 1,000 participants. They had to be born between 1995 and 2012. Limited household income to below 80,000 per year. So 80,000 a year is about the median U.S. household income. So I'm interested in lower than the median. Interested also in people whose parents did not attend college, so they don't come from that background. And I limited the sample to 20 cities across the U.S. Midwest and South. And the other thing I did in this survey to make sure I had a good balance was I forced a gender balance. And so I had 50% of respondents were female, 49% identified as male, and 1% identified as gender non-binary other. Now, amongst all the data in this data set, I had over 35,000 data points. It's rare for me to do a survey this big in user research. Typically, we might do like 20, 30 user interviews, maybe a survey of 100 or 200 participants. This is on a much bigger scale, much bigger data set than I'm accustomed to working with. Traditionally, to hand sort all the data in this data set, working with a UX team, maybe 2 or 3 UX designers or researchers, would probably take us a couple weeks. Really working full time, 8-hour days, 5 days a week to crunch this data. So what I did instead was in 2023, ChatGPT-4 had just come out. It's a pretty robust model. So I used that model and I basically created a custom ChatGPT-4 model trained on this data set. And I also threw in the data set some of my UX and HCI textbooks, and so it would have some other data about like how to create user personas essentially. By doing a set of queries, I was able to basically sort of build up user personas using, not exclusively, but heavily using ChatGPT custom trained on this data set. So some of the things, that ChatGPT could quickly generate proto-personas. It initially created 5 proto-personas. And these, the groupings were around gender and ethnicity. I could easily, I actually experimented, I could ask it to regroup around other arbitrary data points, such as age or location or other things like that. But anyway, those are the groupings it selected initially. I did further refinements in data discovery through additional prompt inquiries. So just asking additional questions like, what is the typical, sort of tech stack of this user persona, for example? Or I had questions in their data points about attitudes about social and economic issues and things like that. Now, I did have an assistant who worked with me on this, and we actually went and manually checked the individual user responses that matched each persona. We didn't check all of them, but we did a sampling to basically check like how accurate was ChatGPT at doing this. And generally, we found it to be pretty accurate. I'd say over 90% accurate. And we were going in and making adjustments as we kind of saw appropriate. And so persona data was adjusted and augmented based on manual research. There are things like persona stories. We actually wrote those stories, but we extracted the data points through conversations with the GPT. And I would say that the GPT probably found patterns in the user data that would have been very difficult for us to find manually if we'd done this manually. And it certainly saved us a lot of time. We were able to do this within a few days instead of like, weeks, basically, with a lot of resources. These are examples of some of the findings. We also use Gen AI to create headshots for each of the personas so that we'd have a face to them, but we're not using real people's faces, so that the data is anonymized. But some of the interesting things that we found about that were sort of commonalities across all these personas, things like they're more progressive than their parents, but they're more conservative than coastal Gen Z. There's a strong resentment towards the college educated, the coastal elites, and the billionaire class. And so there is this sort of tension that they see themselves as being separate from Gen Z or living in wealthier coastal cities. And these other really interesting patterns, again, that we probably would have had a hard time picking up some, if not all of these, if we had coded the data by hand. Some additional data points like, what is their tech stack? And what are some other sort of characteristics and proclivities about them? So this is a way in which, using these AI tools exponentially accelerated the process of doing user research, data analysis and synthesis, and getting some really rich user personas out of it. That again, we went and validated the data to make sure that it was as accurate as possible. Now, here's another example. This is a newer tool. It's called syntheticusers.com. And this is a platform that uses AI to generate realistic user personas and feedback based on large data sets. And so they have their own huge data sets of information about people, about supposedly real people. And through a series of prompts or questions, it can generate user personas for you instantly. And it can do other things like generate like user interviews, and you can tell it what subject you're or what the thing is you're designing and whatnot. And so it will conduct interviews that are contextually appropriate to the topic. So this is an example. It produced a couple of personas for me. And here the prompt was, I'm designing new educational products for people who want access to high-tech careers, basically. Now, these AI-generated personas or testers raise, I think, really critical ethical questions about things like accuracy and bias and consent. And something that we've seen a lot of research on, that there's a lot of baked-in bias with these AI models. And the reason why is because they're trained on human data. And of course, there is bias in human systems and human societies. And so it's reflecting back the human bias that is practiced in the real world. So if we're looking to eliminate bias that presents a problem, it's going to basically reflect back and amplify the bias that's already sort of inherent in systems there. And so, for instance, this user persona here, who they call Jamal Washington, you can see here it's generating an interview. We can see it generating in real time in this recording. And like some of the responses, it's using, Jamal Washington is supposedly African American. It's using some Black vernacular in the responses. And there's a risk that that's actually stereotypical use of language, because that's not a real person there. Again, this is AI generated. So the question is like, is this really sort of an accurate representation of what this interview would look like if this is a real person? Or is it reflecting back sort of a bias in the data set? Now, synthetic users claims to have over 90% accuracy. I don't know how they measure that. I don't know what their methods are. But it does raise ethical issues, and many designers in the field find tools like this to be unethical for these reasons. Another ethical issue I'll bring up is that unlike real users, where you can ask a person, hey, do you want to do an interview? Do you want to test this product? And they can consent, they can give informed consent to participate or not. With synthetic users, they can't give informed consent because it's not a real user, it's a simulation of a user. And so this also, from an ethical standpoint, sort of challenges our standards for how do we conduct ethical research and human-centered design. And is it really human-centered design if it's not a real human, it's a synthetic human? I'd say the jury is still out on this, but tools like this, I would say, are being used in the real world, but at the same time, they're quite controversial. So it's something as designers to be aware of. If you use these, you may get sort of negative pushback from other designers. Now, there's research that shows that the large language models, the LLMs, produce inaccurate information on average about a third of the time, about 34% of the time, actually, in this particular study that was done by Katarina Bellum at UC Irvine. There's a study that was published on Arxiv, sorry. And so this produces a problem. It makes blind trusts in the outputs of LLMs quite risky. And we've seen this. You've probably seen news headlines about things like lawyers quoting fake legal cases in court. And it was a legal case that was generated by an LLM, like ChatGPT, for example. It wasn't a real court case. It was an average of what a real court case might look like. And so it's something to keep in mind as designers. If we're using these tools with care, fact-checking results, applying critical judgment to how we're using them, they can dramatically accelerate ideation, research, content generation, these sorts of things. They're especially useful for synthesizing insights, generating design variations, simulating user perspectives. LMs are great at sort of taking large data sets and producing those kinds of outputs. But they also can be inaccurate about 34% of the time. They don't have that sort of contextual awareness. And so without the right oversight, there could be problems with them. But with the right oversight, these can be really powerful collaborators in the UX design process. And so a message I would say is, yes, use AIs, but check your AI's work and make sure you can check your AI's work. That's something we'll talk about a little bit later too, is sometimes it's not always transparent what the AI is actually doing. Next, I would like to talk about AI design tools. And so these are tools not for research, but for actually generating design, either content for design, things like doing rapid prototyping, generative creativity, rapidly, producing different iterations of something or being able to swap out different styles, and then automating a variety of different tasks that come up in the design process. So the first tool I want to share with you is Google Stitch. And this is a new tool. It's still in beta mode. I've just been playing with it for the last 10 days, basically. And it's a really interesting tool that helps UX designers rapidly generate high fidelity layouts from text prompts. And so it can turn ideas into screen designs literally in minutes. So it streamlines things like the early prototyping process by automating repetitive UI decisions and visual exploration. If you just want to generate a quick idea, test it, maybe generate a bunch of iterations, again, it can do this with just some prompts and a few quick clicks, and it can do it very quickly. And so iteration becomes faster, making refinements to design becomes faster. It has export tools, so it can export, say, to like Figma, where you can copy and paste designs to Figma, and then sort of take your design and development into that phase if you want to. So essentially what Google Stitch is doing is it's offloading low-level execution. So the days of like you start with a blank canvas and you start to draw elements from scratch, or maybe you have a UI pattern library and you're copying and pasting elements from the pattern library and starting to create a layout. Those days are sort of rapidly going away. Instead, this can do that for you basically, within minutes, like I said, or within seconds sometimes. And so really what this is doing is changing the role of the designer from focusing on the UI layouts to instead focusing on things like strategy and flow and user experience, and acting more as an art director. So the designer still has to be very well versed in UI design and know layout, be able to critique it and point out what's working, what isn't, what's a design mistake, what are some opportunities for improvement, and also how to write really good critiques for the tool to be able to iterate on. And so to use Stitch, and especially to use it ethically, designers should review and refine its AI-generated outputs. You want to ensure things like accessibility, inclusivity, and alignment with human-centered design principles. And then lastly, kind of one of the most powerful features is it does generate live code. And so you can go from design to working code also in one step. And it's just one of the many tools that are doing this kind of one step from design to code, essentially. So the general Google Stitch workflow is you generate layouts in Stitch using natural language prompts. That's something we saw kind of in this last slide here. Then you edit layouts, you edit the structure, styling. You can do this very quickly with Stitch's design editor. So it has a simple design editor. You can export designs in Figma compatible formats. And then you can import those into Figma and then start working on more sort of detailed visual design and interaction work. And so this is actually one of the designs that was generated in Stitch right here. So there I have a prompt. I click on generate designs. You can see it's kind of working through it. It does a good job kind of telling me what it's doing also. And it wants to validate like, oh, are these some of the things you're looking for? Some of the pages or screens you're looking for? And I say, yeah, I click on make them all, make all those screens. So it starts working on that, and fast forward a bit here. So those are those screens that it generated. And I now could go through, these are all editable elements within those screens. I could go in through and refine those things. And of course, a lot of the content is placeholder content. But it's already been customized also to the topic or my sort of business goals that I'm designing towards. There's that same design in Figma. So I took that first screen into Figma here. And for those of you familiar with Figma, you can see it imported all the layers. So those are all editable elements. I can now go and start working on that. So you can edit all those components. I now have a starting point. I've saved hours and hours of work of creating those layouts. I can now go and customize it at this stage. So really compressing the workflow there. But at the same time, it's still allowing the hand of the designer to really guide like what the design is doing and what the final execution is going to look like. Here's another tool. It's called UX Pilot. And so this is an AI-assisted tool that generates user interface layouts from text prompts, just like Stitch. And so this allows designers to quickly explore and iterate on ideas. And it supports exporting designs to Figma for further development or into working code for testing and implementation. So very similar tool to Stitch. Now, this also allows users to create and design reusable templates and components and things like that in Stitch, and so, or in UX Pilot, sorry. So Pilots, in some ways, it works with Figma, but it's also trying to replace Figma. But it can do this in a way that's automated that helps to maintain consistency across multiple products if you're doing multiple projects for the same client, for example. And so this greatly improves the efficiency of workflows by automating a lot of the aspects of layout and production. Now, Figma has become really kind of the standard tool in UX design. And Figma has been introducing some new AI features. Some just got introduced in the last couple of weeks. But one of the areas where they've introduced new AI features is in FigJam, which is more their sort of ideation and sort of diagramming and collaboration platform. And so a lot of the features in FigJam help to speed up design workflows. So they allow users to do things like generate UI elements, generate text content. So it's using generative AI to produce text. So you can do content generation right there. Produce design variations directly from prompts. So you can have a design and say, hey, make this more minimalist, make it more like Apple's glass morphism kind of aesthetic, etc. And so designers can quickly edit copy, they can resize components, and even restructure whole layouts with simple text-based commands here. There's also things like creating like automated customer journey maps in FigJam. So you can do that through a text prompt now as well. So these tools, they still require designer oversight, but they're offering really meaningful support in accelerating production and iteration in the design process. And it's something that Figma is going to continue to roll out more of these sort of assisted tools. Another tool is Replit Ghostwriter, and so it's a pretty cool platform. It's a code generator essentially, but it has a visual UI tool as well. And so this enables designers and developers to generate live deployable code from prompts, so you can build working web and mobile applications. And what this really does is it merges prototyping and production into a single continuous process. And currently, you may have to, develop, really extensive prototypes, Figma or Protopie or some other prototyping software. But then you hand off to a developer who has to translate that into actual working code. They actually have to rebuild it all from scratch, essentially. And so this really compresses that process. And to an extent, the prior two tools do as well. But Replit is considered really a tool for building deployable applications with working code. And so this integrated workflow really helps to reduce handoff delays between designers and developers, and it can foster a more iterative and collaborative approach to product development. And so we actually ran an elective course at Art Center this summer in vibe code prototyping using Replit. And so we were using this platform. And what was really amazing is that on day one, the students had live working apps already that would work on a smartphone or a web app that would work off of a web server. So to be able to get to there in day one, is pretty remarkable. Here's another tool called UIZard, and this is a UI design tool that transforms the UX and interaction design process by enabling designers to quickly turn hand-drawn sketches or text prompts into wireframes. And so the ability to actually use designer sketches and then turn that into higher fidelity, or let's say more refined design assets, is a special category that I think is really compelling, because it means that the designer's vision is really still critical in the process. And it's something that I think is a danger if you're using an image generator. If you just put in a text prompt and say, hey, make me an e-commerce website, that is inspired by, Nike's website or something like that, it'll spit out a website, and you can just copy that. But there's really the authorship of the designer is not really that present in that process. The AI is just auto-generating something. I think there's really something that's important and foundational about doing ideation with pencil and paper, in that there's less sort of a technological intervention between the designer's ideation and the ideas actually getting onto paper. And so I really encourage designers to sketch. Even if you're bad at sketching, it's still a really critical part of the process. What UIZard can do is take your sketches and turn them into wireframes or into mockups or prototypes or UI templates and things like that. So it makes it really easy to go from lo-fi to hi-fi, and it just compresses that process. But it still means that the designer's agency is critical, especially in the sort of early ideation. But I think this is a particularly compelling platform. So going from mockup to screenshot, also, you can take a screenshot of something you like, import it, it turns it into an editable prototype. You can pick it apart then. So it's kind of amazing, its ability to sort of take a certain type of asset and transform it into a completely higher fidelity and completely editable asset. And that's something that really kind of turbocharges the design and ideation process. Now, VizCom is another tool that also takes your sketches and turns it into renderings. The big difference with VizCom is that it can not only do 2D renderings, but it can do 3-dimensional renderings, and it can take a 2-dimensional sketch, for example, and turn it into a 3-dimensional object or 3-dimensional environment. And this is something that we get into in interaction design at Art Center when we're designing for 3-dimensional environments like automobile cockpits or IoT devices, so physical products that are interactive and have embedded technology, or ambient architectural technology. So interactive technologies are embedded into the physical environment around us, into architecture or even furniture design, things like that, wearable technology. Then we've got to start thinking 3-dimensionally as UX designers. So this tool allows us also to sort of compress that process, to ideate something in 3 dimensions, but on paper, and then very quickly take it to a 3D model that then we can edit in Blender 3D or SketchUp or some other 3D software. I want to show you this short video. VizCom has become quite popular in transportation design, but we're also experimenting with it, with interaction design. But this is showing how to, basically take a pretty low fidelity sketch, not a very great sketch, and make it into a really quite remarkable 3D model.
Hey everybody, Gerge here. Today it's going to be about how to keep the VizCom renderings as clean as possible and as true as possible to your sketch. So let's jump in. First of all, I'm going to import a sketch to the canvas. It will automatically start describing it. That will be a perfect prompt. Now I select the car shading palette, which will give us a very clean volume that we can use. Use something around 90% drawing influence that can ensure that it will be on your sketch. After we get this base, I'm gonna go to my asset libraries, because here I pre-uploaded a few let's say wheel presets that I can choose from. And now I can just drag and drop them onto the canvas, but feel free to just bring in these wheels from any source. This can be done in Photoshop as well. We can just place the wheel with the help of the move tool. And then we can duplicate the layer to make the wheels nicely fit the vehicle. Now the key thing is going to be the environment feature. The environment feature will require us to have an environment reference, free to import this from any source. And now here I can just simply prompt for concept vehicle in a simple studio. Prompt is not absolutely necessary, but it's always worth to reinforce your intentions with it. The environment feature is going to make the results very clean, and it will stick to the original rendering. So we get this nice and clean result. It did not add in any unnecessary details, which is very cool. Now we can even sketch in some headlights, taillights, and other graphic elements, even text if you want. And now we can rerun it once again with the same settings. So just click generate, and then the new result is gonna pop up. We can now go outside to the infinite canvas view to actually animate these, maybe to have a turntable animation to check out the rear and the front views of it. So for that, you can just access the animation feature in the workbench view. Here, I can just say vehicle is rotating around. And I can just hit it a few times. So now we get a cool rear and front interpretation according to this sketch rendering that we just made. If you want to make sure to explore the front and the rear views as well, mirror the original image and retry it with the mirrored version. It will rotate it according to the other view. I hope this was a helpful little workflow. Let me know if you have any questions.
So that was an example that's just a 2-minute video we saw in 2 minutes, almost in real time. It's a little bit edited, but almost in real time, went from a very low fidelity sketch to a 3D model that you could rotate, has some details. And again, like I said, you could then export that in an editable 3D file that you can take into 3D software and continue to refine. So this is an incredible compression of the production process for designers. To go from sketch to 3D model would have taken many hours of rebuilding it basically from scratch in the 3D model. And now it's like a couple of minutes to go from my concept sketch to a working 3D model. So some of the implications for UX and interaction designers, there's a need to learn prompt literacy to get good at prompting. And there are some elements of good prompt writing. Oftentimes designers are curating and not just creating. And so we also saw with VisCom, there's some reference images that were brought in, the wheel design, a sort of environment or another rendering to show, what the background should look like and things like that. So using those reference images, almost like vision boards or mood boards, become sort of design tools again. And also thinking about multimodal, multi-agent collaboration. That's something that a lot of UX designers who are really diving into this process, using multiple agents in different ways at different points in the process. Christopher Nozzle is a great thinker in this field. He's an Art Center alumni. He wrote a great book on designing for agentive technology. He said that agentive tech is not about replacing humans, it's about empowering them. And I think that's really important to consider. Also in the face, of a lot of these tech companies saying, we really love to replace people with AIs. And what we're finding, is that AI human collaboration is actually much more powerful. AI replacing humans actually doesn't work so well. Now, some of the elements of good prompt writing are around, clearly stating what you want the AI to do, have a clearly stated goal. Give background or constraints about the context of what you want the output to be. Include specific details about the requirements for what you're looking for. And also specify how you want the output to be. Is it text output? Is it in paragraph or list form? Is it working code? Is it an image? What size, what style image is it, et cetera? And so a lot of specificity, a lot of practice, can go into this. But being very good with language, being able to describe things well, become really important skills. The other thing is that creating custom agents and chat GPTs that are trained on your own data sets allows designers to tailor outputs to their specific design systems, as well as things like the brand voice, the user contexts. And so this leads to faster workflows. It automates tasks like interface copy, user flows, prototyping. And it also enables deeper insights by simulating realistic user behavior or providing feedback that's grounded in actual research data. And so this is an example. This is a custom copilot. It's a design copilot I built in ChatGPT that's trained on my own custom training data set. And so this one I trained basically on all my textbooks and a lot of articles, research articles, about interaction design and UX and HCI and all that kind of stuff. And so I can ask it questions. This basically becomes an agent I can ask to retrieve information from the library of books and research materials that I use in my practice. And it does it through a natural language process. So I don't have to think, what book is this thing and I'm looking for? Instead, I can ask it, who talks about, design for situation awareness and what do they say about it? And then it can aggregate those responses for me. I also find when you build your own tools, you get better results out of it. So I've started doing this actually for individual clients and individual projects as well, building a specialized tool. Now, as AI tools become more common in UX and interaction design, there is a risk that over-reliance can lead to bland and average-looking interfaces. And it's important to recognize that the LLMs don't really know what they're doing. They're just looking at a large data set, and they're doing a lot of pattern recognition. They're giving you back kind of a homogenized output of what the average-looking correct answer would look like based on the string of words that were in your query. And so if designers treat AI as a final author rather than as a creative partner, we risk losing the agency of the designer. We risk losing the uniqueness and innovation that human insights can bring to design. And so for that reason, I think it's essential that designers use these tools to explore new directions and spark ideas and push boundaries, but not just automate predictable patterns. So AI should expand our creative range, but not compress it into the median or sort of the average. We see there's a lot of the AI-generated UIs. Boy, they look like a lot of the other UIs that are out there in the world. And there's a reason why, because they're trained on all those UIs. So they're going to give you back an average of what those other products look like. Now, in this next section, I want to talk a little bit about designing for agentive systems. And I realize we're running a little over time, so I'm gonna go a little bit quickly through this section. But there's some principles about agentive UX. And so the first is that AI acts on the user's behalf. AI learns, adapts, and makes decisions sometimes. But the user remains in charge. And I think that's something important to keep in mind when designing these systems. Now, there's a great paper that was published earlier this year by Dr. Micah Ensley. And Dr. Ensley is one of the world's leading experts on design for situation awareness and automation technologies. And so this paper called Ironies of Artificial Intelligence outlines 5 ironies of AI that Ensley identifies. And these include, not being truly intelligent. They appear to be intelligent, they're not really. They're opaque and evolving. They have poor human adaptation. They contain hidden biases. And also natural language interfaces means that we sort of instill false trust in these systems. So irony number 1, these systems are not truly intelligent, points to the fundamental limitation that AI systems, including the LLMs and image generators, rely on, which is large pattern recognition rather than true understanding. And so they can generate remarkably convincing outputs, but they often hallucinate facts, or they produce what are called brittle results when they're pushed sort of beyond boundaries. And so this is an example. I asked it to produce a futuristic-looking folding smartphone. You can see, and this was done by DALL-E. It's very typical output by DALL-E. This phone doesn't fold in a way that folding smartphones should naturally fold. In fact, this looks like it's been damaged, so not quite right. And also you can see that the text on the screen of the phone is kind of glitchy. The icons are kind of glitchy. They look familiar, but they're glitched out. These are the kinds of details that it often kind of glitches or hallucinates. And so if I'm doing real product design, this is not useful to me. This is AI slop here. It doesn't understand the physics or the sort of contextual correctness of things like text and things like that. Now, I did get the hands mostly correct. This is something that the LLMs often glitch on, is hands. You'll often see like too many or not enough fingers and things like that. It'll sort of mess up human anatomy. Irony number 2 is that the systems are opaque and evolving. And so what this means is that large language models generate responses that are based on patterns in massive data sets, but they can't explain why a specific answer was chosen or how it was formed. And so their internal reasoning processes are not transparent, even to the computer scientists who created these models. So even the creators, even the engineers who made them, they don't have a way of understanding or explaining their behavior. When we say it's evolving, it also means they're constantly tweaking the algorithms, and also the training data set changes. And so when there's a change in the algorithm or additional data is added, behaviors also change in ways that are impossible to predict. Irony number 3 is that there's poor human adaptation. People have a tendency to overtrust agents, and there can be a failure to adapt or intervene with agentive or automated systems. And so there have been, for instance, some experiments done. MIT did an experiment earlier this year where they had a bunch of basically AI bots serve as employees of a company. They found that the AI bots failed miserably. The bots missed deadlines, they misunderstood instructions, they made costly errors, they got stuck in feedback loops. So it really revealed how unprepared both AI systems and also human supervisors are for this level of delegation. They're not ready to be employees yet. They're ready to be agents that assist us, but they need constant human oversight and intervention. And so the assumption that AI can replace human judgment without oversight is premature and very risky at this point. Now, there are also hidden biases. So this is irony number 4. And so this is about how AI systems often inherit and amplify the biases that are present in training data. And so users can largely remain unaware of these kind of embedded limitations. And these can affect everything from image recognition and language generation to decision-making in high-stakes systems. And so a really powerful system is seen in self-driving cars, where the handoff between the AI and the human control is statistically the most dangerous moment in the trip. Drivers are typically lulled into a false sense of security. They overestimate the AI's capabilities. They lose situational awareness. And this leads to them reacting too slowly when they're suddenly required to take over, or not realizing that the AI has stopped driving, basically. And so this illustrates how unseen flaws in AI systems combined with misplaced trust can create new kinds of safety risks. An example of algorithmic bias from training data is with facial recognition systems. And so facial recognition systems have been shown to misidentify Black and female faces at a significantly higher rate than European male faces. And this is due to imbalanced and biased training data sets. They don't have enough training data to be well-versed in a diversity of different faces and skin tones and whatnot. Oftentimes there are biases in the hardware too. If the hardware doesn't have the sort of color and lighting range to be able to see also darker skin tones in different lighting conditions. So these disparities, they not only reduce system accuracy, but they can also lead to real-world harms. Things like wrongful surveillance, exclusion or discrimination in high-stakes contexts like law enforcement or hiring practices and things like that. And then the last irony number 5, natural language equals false trust. And so when we converse with these systems and they seem to have personality, they can converse in our natural language. This makes us assign kind of more agency and give more trust to the system than is warranted. And so this essentially kind of masks the system's uncertainty, its limitations, and this leads users to misjudge not just the factual accuracy of the output, but also the emotional tone or the authority behind it. And we've seen this also, like people trusting outputs from an LLM that proved to be false, or also thinking the AI has sort of emotions behind it. And so as a result, users might misassign the AI level of agency or personhood that it actually doesn't really possess. And so this can really distort decision making and also erode accountability in critical situations. Now I want to come back to Chris Nozzle. He's as I said, an alumni of Art Center. He's written a couple of great books that I use in my classes, and this is one of them. It's called Designing Agentive Technology, AI that Works for People. It's really a groundbreaking book. I think it's one of the first books on this subject. And in it, he provides a framework for designing AI systems that act on the user behalf while remaining transparent and trustworthy. And so he identifies these 4 rules of inspectable behavior, narrow task scope, real-time feedback, and override control. And I'll run through those real quickly here. So inspectable behavior, the user must always feel in control, even when the agent is doing the heavy lifting. And so this is an example. This is that custom AI bot that I built in ChatGPT. It's designed to be a design co-pilot. And because it's trained on my own data set, this actually makes it much more accountable than just the sort of open-ended ChatGPT. And so each critique given by the AI should be justifiable in the training data, or when it gives me a response. I can fact check it. I can say, why did you give that response? It will go and quote, it will say, well, I critique this and this design layout because of this principle from this book on HCI. Or I found this quote in this research paper that supports me giving this feedback here. So it's a way of having inspectable behavior in the model. And if I don't agree with some output, or I'm suspicious of an output, I can always investigate further. Narrowing the task scope. And so a lot of the companies, they're chasing AGI, or what's called artificial general intelligence. And so this is largely, understood to be AI that's equal to sort of human intelligence capabilities. The idea that it could tackle any number of tasks that a human could. Well, in the real world, in particular right now at this point in history, AIs with a narrow task scope perform much better. And so an example is the Roomba. It's a really good AI agent because it only tries to clean the floors. And sometimes it'll entertain your cat too. But that narrow focus allows users to understand, what its behavior is, understand what the expectations are, and also to judge whether it's doing a good job or not. It's pretty transparent if the Roomba vacuum cleaner is working or not. Real-time feedback, and so a system should provide ongoing updates about what it's doing, and this is really essential in agentive systems. And so great example is Uber. Uber is using an AI to negotiate basically between the rider and the driver. And it's also doing things like looking at traffic and calculating travel times and things like that. And one of the things that we'll do is show you the location of the driver once it's matched the rider and the driver, and show how far the driver is to the rider. And so this helps to facilitate a smoother pickup time by being able to coordinate not just a place, but also a time and space. And so I have to be at the right location for the driver to pick me up, but I also have to be at the right time when the driver arrives. And so this gives both the driver and the user better situational awareness. And here in these two screens on the left-hand side, we see the passenger view. So the passenger can see, okay, where is the driver? How long is it going to take for them to reach me? Who's the driver? What kind of car are they driving? So I can help identify them. And on the right-hand side, we see the driver's view. So the driver is seeing, okay, where is their location? And that little green marker sort of marks where the pickup spot is for the user. And the fourth and final principle is override control. And this is really important. Users should be able to take back control from the agent if needed. And this ensures transparency of the system, as well as better flexibility and safety. And so in semi-autonomous cars, for example, a lot of cars nowadays have assistive driving features. They're basically partially self-driving or situationally, partially self-driving. But in these vehicles, the driver can take over the steering wheel, or they can hit the brakes to stop certain automated actions. And so this ability to override ensures user safety and confidence in the system. And this is an example. These are the controls for the Lexus safety system used in some of the newer Lexus cars that have assisted driving features. And so you can actually adjust, which features are on or off, or when they activate, or how the user can intervene with these various systems. So what does this mean? Means new roles for UX and interaction designers. Designers are becoming more systems thinkers, more behavioral architects, more builders of trust with systems, and collaborating with the AI, not being replaced by the AI. And it's something I've noticed actually a lot of the job fields, the ones getting replaced by AI or reduced, like let's say by AI, and the ones that are not. And I'd say the general pattern is that jobs that generally kind of have linear tasks that are easy to quantify and sort of lay out in a step-by-step process, those are easier to automate for AIs. So it's a little bit easier to automate a software developer, although you still need software developers. And companies that are replacing software developers with AI bots are actually running into a lot of problems. And I think they're going to backtrack and go back and rehire a lot of those engineers they laid off. With UX and interaction designers, this field has always been inherently about nonlinear, often non-quantifiable problem solving. And so it's not a field that's easily replaceable by AI. And that's why instead we see AI tools being injected in the process at every step, but not a replacement of UX designers, actually a need for more UX designers. And also growing into these new sort of roles into systems architects and strategy and whatnot. There's also a shift from traditional user interfaces to AI-powered ecosystems. And this is marking a fundamental transformation in the way we approach the design, especially of digital products. And so designers used to be focused on isolated apps or device-specific kind of interactions or UIs, user interfaces. And now they're focused more on creative agentive experiences that are persisting, operating across networks of devices, smartphones, wearables, vehicles, appliances, IoT devices, ambient environments. These AI-driven agents are no longer confined to a single interface. And so they can follow the user from one context to another. This also means that they have to maintain awareness of preferences and habits and goals and past interactions in order to remain functional. And so this requires designing, for very different types of systems. Now, lastly, I want to talk a little bit about how we approach AI in Art Center's graduate interaction design program. And a lot of this also is the same as our undergraduate program, so I shouldn't just limit it to our grad program. But this is the domain where I have the most purview. So in our grad IXD program, we're embracing AI not just as a tool, but also as a transformative force that's shaping the future of design and society. And so we're using AI tools and also engaging in critical inquiry about AI tools in every single course in the program. And it's something that's been kind of a core feature about the program, is that we're constantly embracing the newest emergent technologies in both kind of practical and hands-on ways, but also in very sort of critical and academic ways. So our students are engaging with AI through hands-on experimentation, rapid prototyping, applied projects that are exploring real use case scenarios across different platforms and domains. And so whether we're designing with generative models or designing conversational interfaces or intelligent agents, students are gaining practical experience integrating AI into workflows and systems. And systems design, systems thinking also is like a core tenet of our program. So really kind of conducive to working in this area. Now, we're seeing that there are these shifts happening in the UX and interaction design professions, and some of these shifts are really AI driven, and some of them are because of also other sort of macro historical drivers. But the integration of AI into research and design workflows is accelerating tasks. So things like I talked about before: user research, prototyping, content generation, usability testing, enabling designers to iterate faster and also make more data-driven decisions or data-informed decisions, let's say. Now, at the same time, interaction design and UX are expanding beyond traditional digital products into things like complex high-impact industries like transportation, finance, energy, logistics, robotics, service systems, electronic devices. We see a convergence with other fields, like with interactions, with graphic design, with industrial design, with engineering fields and things like that. And also into service design systems. And so service, the service industry represents more than 70% of the US economy, for example. That's pretty typical in the more sort of industrialized economies. And so service design is another field that's growing a lot. And so basically any of these other fields where technology is becoming embedded and human-centered design is critical to navigating that technological change, we see an expansion of UX and interaction design. And so another thing about the jobs outlook, and so the jobs outlook, unlike some fields which are going to see a rapid reduction in jobs because of AI and automation, UX and interaction design is almost the opposite. And so in the next 5 years, the field is expected to grow by between 35 to 50%. So by between 25 this year, 20 and 2030, up to a 50% increase in jobs. So it's a huge increase in jobs. And again, that's because of the expansion into these new fields and the expansion of roles for UX and interaction designers. So this is creating new opportunities to design intelligent systems, to design adaptive interfaces, as well as cross-platform service ecosystems. And so it's working on different scales. So organizations across industries are recognizing the need for thoughtful strategic design to guide how users interact with complex technologies and complex service design systems. And so as a result, we're seeing roles in these fields not only becoming more essential, but also more diverse. And so they're spanning everything from AI ethics and behavior design to like service design and orchestration and multimodal interactions and things like that. Now I wanted to share just quickly some recent student projects that are incorporating AI. So this is one by one of our alumni who graduated last year. And this is a simulation for a mixed reality system for astronauts exploring the moon and prospecting for water on the moon and building lunar bases and whatnot. And this was in response to a real NASA RFP.
Hey, Wookie.
Hey, environmental conditions are stable and your vital signs are all normal.
So here we see the astronaut conversing with an AI called Wookie. That's an AI assistant for astronauts. You can see they have access to some heads-up display data there. I won't show the whole simulation here, But essentially, this was designed around the really extreme working conditions in this environment. What types of technology systems are going to work? How is the mixed reality system and the AI going to help astronauts see at nighttime? Nighttime on the moon, it's pitch black. So how do they still see the environment? And how can they use technologies also to do things like soil analysis and find out like where the water is? So here they have like these maps basically of like soil chemical analysis and things like that. But the AI system, the interaction with the AI system is the primary sort of interaction modality with this system. And it's also designed so that, if they become kind of out of communications range, the system can still work untethered in this remote location. This is another project, actually one of our students in our capstone thesis class this summer is developing this for her thesis project. And this is a fully developed game being developed in Unity called Hedgie Town. So the main character of the game and some of the other non-player characters are AIs. And so AI agents have actually been sort of long developed in gaming. And so a lot of what we know actually about how to develop AI agents comes from the gaming industry. So this is cool. It's kind of changing the gaming dynamics. It's meant to be more of a relaxing game that is pushing a more healthy kind of relationship with technology rather than an addictive one. And it's using these cool kind of retro 8-bit arcade game graphics. This is a design for the interface for a gem car. So gem car is a little electric neighborhood EV vehicle by one of our students who graduated last term. And so a lot of AI is used in this to enhance situation awareness for the driver, help to be able to use the systems without the driver having to pull her attention away from driving towards the interface. So showing a little bit of the layout here, the navigation, vehicle controls, the entertainment system. And also we saw this earlier in the deck as well. This is a 3D mock-up of the student looking at how the interface would actually work in the 3D environment. And so we can do these full 3D mock-ups to do the HMI design. This is notable. This student worked a lot with like designing AI tools into all the projects that she worked on. And she now is working at ProRata.ai, which is one of the major kind of AI companies in Silicon Valley. And this I thought was cool. These are just a couple of slides of one of our current students reflecting on some of the things he's learned over the past year. And so, thinking, revisiting coding and kind of revisiting algorithmic thinking in a new way. And so in the fall in our creative prototyping classes, our students learn some coding, but really they're learning algorithmic thinking. And so they don't have to become great software developers, but they have to be able to sort of think in algorithms and think in code and whatnot. Thinking about service design blueprint, using service design blueprinting as a way of cultivating systems thinking. Designing with and for artificial intelligence in mind. And so what do those human-computer interactions look like, and how does that change the user interface and whatnot? Using pluriversal research approaches to make design more inclusive and things like that. So just showing how AI is touching really all of the student projects on both sides, both how AI is used in their designs, but also how they're using AI to actually do the design process. Now, a little bit more about our graduate program, in case you're not familiar. And so our Master of Design in Interaction Design is a 1-year, 100% online master's degree. And this program was designed for working professionals. So we actually did a lot of user research when we designed this program. We discovered there are a lot of working designers out there who'd love to come back and do a master's degree, but they can't. They can't quit their job. They can't move back to Pasadena. They may be living somewhere else. And so the classes are all on evenings and Saturdays. And we designed it such that you can keep your day job, you can still live in your home city, but you can also get a really rigorous master's level education at Art Center. And so we cover things like advanced prototyping. We're always kind of updating our tech stack and what tools we're using, advanced UX research methods, forecasting and speculative futures design. As far as I know, this is the only interaction design master's that is really teaching formal future casting methodology. And finally, design leadership and strategy. A lot of our grads, they say, okay, I'm kind of entry or mid-level designer, but eventually I want to move up to management or leadership, and I want to think about design as strategy. So how do I do that? It's a completely different skill set. So we're really preparing our grads to level up, to become senior level designers, and also to be prepared to enter management and leadership roles. Another thing I'll say about the job market, we're seeing an expansion of jobs, but it's been very asymmetric. We're actually seeing fewer entry-level jobs and a lot more senior and design and sort of leadership level roles. And this is an effect of AI technologies. Now, a senior designer can do the work of multiple people, or they can at least do that work much quicker. And so we're seeing also that graduates with an advanced degree and with some more experience and some more fluency in these emerging technologies are more prepared for these more plentiful senior level and leadership roles.